Today we reviewed reflections, translations, and rotations. And I just want to remind you that a reflection can be referred to as a flip, a translation can be referred to as a slide, and a rotation can be referred to as a turn. So let's consider this ordered pair or this point here in the coordinate plane, 3, 1. And we are going to reflect this point over the line, x equals -4. So our first task will be to reflect over the line, x equals -4. Okay, so I paused the video so I could write the instructions in black ink. Next, I'm going to go ahead and graph that line, x equals -4. You can use a graphing utility online, Dustmo's graphing calculator, to graph this equation if you need help graphing that line. But anyhow, to graph the equation of the line x equals -4, we know that this is going to intersect the x-axis at -4, and it's going to be perpendicular to the x-axis. Okay, and next we're going to go ahead and perform that reflection. There are two ways that you can do this that we are going to look at together. The first way is just simply counting. I see here this is a vertical line, and so my line of reflection will be a horizontal line. So this is really easy. I can just count that perpendicular distance. So from the line I have 1, 2, 3, 4, 5, 6, 7 units. I'm going to reflect this point over 1, 2, 3, 4, 5, 6, 7 units, and that would give me the ordered pair, -11, 4 as the answer. Now I made this dot very light intentionally because I want to look at this using a second approach that students were exposed to today in class, and that second approach is using patty paper. Now for our state test at the end of the year in geometry, you all will have the ability to use patty paper on the state test. And so patty paper is just wax paper. We use it for tracing. I'm going to place this patty paper over my coordinate plane, and I'm going to trace the origin. I'm going to trace over my point that I am interested in reflecting. And last but not least, I'm going to trace this line of reflection. Now when I pick this up, I can actually see that everything transferred very nicely on this patty paper. You have to use pencil. Pen does not work well on this waxy paper. Now to actually perform the reflection using patty paper, we need to fold this patty paper along the line of reflection, and I need to do it in a way that is neat and precise. So I'm being very intentional and careful about my folding here. And you can see clearly I've creased it on that line of reflection. Now if I fold the paper over, I can see my original point. Let me get rid of this paper from underneath so we can focus just on the patty paper. When I fold the patty paper on the line of reflection, I can actually see my point, my original point, through this patty paper. See, there's that original point. What we want to do is we want to mark where that original point is. So I just drew a little dot there. So now when we open it back up, we can see that reflected point all the way over here to the left. Next, we can take this patty paper and lay it over our original graph. I am being very careful to line up my traced origin back over the origin, my original point on the point, and I'm trying to make sure that everything's lined up nice and neat. And this is not always a perfect way, but this does work. We can see clearly here that this reflected point is mapping over to the point that we got when we counted. And I'm just going to kind of fold this over so you can see. Well, it's kind of hard to do with my hand in the way. But this point here, when it reflected about that line, it flipped over to the other side at -11. I don't know why I put 4 down here. That's 1. -11, 1. Now, usually points do have names, and so perhaps let's go ahead and just name this point 3A. That would be our pre-image A, and our image after that reflection has happened, we would call that A prime. Okay, let's go ahead and look at another reflection. This time we are going to reflect, and let's call this point A again. So let's reflect point A in the line. Y equals 1/2 x plus 2. Again, you can graph this equation or this line by hand, or you can use Desmos graphing calculator to help you graph the line. Now this equation is in what's called slope-intercept form. That is y equals mx plus b. So it's easy to see that our y-intercept is 2, and that our slope is 1/2. And remember, slope is rise over run. We're going to plot that y-intercept first, and then we're going to honor our slope. And let me zoom in a little bit. To honor our slope, starting at the y-intercept, we are going to go up 1 over 2, up 1 over 2, up 1 over 2. And I also like to go in reverse a little bit. So instead of going up 1 and forward 2, I'm going to go down 1 and back 2. Down 1 and back 2, down 1 and back 2. From here, I am going to use a straight edge to graph this line that we are going to reflect in. And I am trying to be very careful about making sure that I'm not being sloppy in my work. And this is the line y equals 1/2 x plus 2. Here I am just going to go ahead and use the patty paper method again to reflect this point A about that line. Okay, the process will be the same again. We're going to first trace our origin. Next, we are going to trace that line of reflection, and we are going to trace our point A. Once we have everything traced, we are going to fold the patty paper along the line that we are reflecting about. And I'm trying to be very careful. Looks like I did a pretty good job. So I'm going to now close this, and I can see here my point. So I know that this is where my A prime will be. I'm writing it kind of backwards and putting the prime in front because I know, well, it kind of made it go upside down, didn't it? I knew that it would look like an A prime flipped over, but I need to work on my writing skills. Anyhow, I'm trying to line everything up to the best of my ability to make it nice and neat, and you can see where A prime landed. Just right here. Now you could also use a counting method here. It's just you need to make sure that the slope of the path that you're taking is the opposite reciprocal of the slope of your line here. So my slope for this line is 1/2, and the slope that would be the opposite reciprocal of that would be -2. So that means, starting at this point, we would go down 2 over 1, down 2 over 1. Well, to go the opposite direction, we would go up 2, back 1, up 2, back 1, and you can get that point. But anyhow, there's that one. Let's go ahead and talk about translations. And I don't have a whole lot of paper. I think I've got one more copy left. So I'm going to use this one for my translation examples. Okay, so we are going to translate point A along the vector 2, -5. This is vector notation. Sometimes people or curriculums will write it differently. They'll do something like this, where they show like the rule. Okay, but I am going to use vector notation. So we're going to translate A along the vector 2, -5, and I want you to understand what the vector is telling us. For the x-coordinate of the vector, it's going to tell us our left or right shift. Our y-coordinate of the vector is going to tell us our up or down shift. If we're moving to the left, it's negative. If we're moving to the right, it's positive. If we're moving down, it's negative. If we're moving up, that's positive. So we are going to physically translate point A first, and then next we're going to go ahead and just do the algebraic approach. To physically translate point A along the vector 2, -5, we need to first start off at our point, and we're going to move over 2 units to the right because we have +2 as our x-coordinate. So we're going to move over 2 units to the right. And then because our y-coordinate of the vector, the translation vector, is negative, we are going to move down 1, 2, 3, 4, 5 units. Now, since we have already reflected A once up here, technically I've already called it A prime. I guess I really should call it something else. I hate to call it A double prime because we didn't go and do anything with this actual point. Maybe we should have done that instead, but I'm just going to call it A double prime just so that way we know it's a different point. Anyhow, so this point here, let's just call it A double prime. And it would occur, or it would be located at the ordered pair 5, -4. I do want to clarify, usually whenever we have a series of transformations, that's when you would keep naming your points. Like I should have maybe reflected this point, called this A prime, and then maybe we should have translated this point somewhere else and called it A double prime, but it is what it is. Anyhow, this is our translated point. We translated point A along the vector 2, -5. So we moved over to the right 2 units and then down 5 units to plot that new point. Now, algebraically speaking, we could have done this without even looking at the graph. If we're translating point A along this vector, all you need to do is add your x-coordinates and your y-coordinates. You can see here that that point would have ended up being 5, -4. So I don't care what approach you take. I don't care if you use counting in the graph. I don't care if you add your components together. It's whatever works best for you. Okay. Another problem we looked at today was determining the translation vector that would be necessary to have one point end up in a different location. So I don't have a lot of space here, so I'm going to bring number 4 up here. So determine the translation vector. Applied to, let's say, point, let's say A double prime here. We're going to use this one. So determine the translation vector applied to point double prime, A double prime, 5, -4. So that it translated to point, let's say A triple prime. I don't know, let's do -2, 5. I do encourage you to pause the video and give it a go, see if you can answer this on your own. There are multiple ways you can go about solving this. Some kids just think about it in their mind. Some kids built equations. Some people just use the graph. I am going to go with the latter and just use a graph. So A double prime is right here, 5, -4. I'm going to go ahead and plot this other point, A triple prime, and it's at -2, 5. Okay, and what we've been tasked with is trying to determine what translation vector was applied to A double prime so that it mapped over to A triple prime. So I need to figure out how many units to the left A double prime had to shift and how many units up A double prime had to shift or slide so that it ended up mapping on top of A triple prime. So let's do some counting. We've got 1, 2, 3, 4, 5, 6, 7 units. 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So our translation vector here, and I want you to remember, going to the left, that's negative. So we're going to have -7 for the x coordinate of that translation vector. And then going up, that's going to be positive. So we'll have +9 for the y coordinate of that translation vector. All right, so let's go ahead and review rotations. We've been studying rotations about the origin and rotations about points that are not the origin. I am going to just illustrate the method of using patty paper for rotations. There are rules that you can apply for rotations, but again, our state test allows you to use patty paper. So I encourage it. Why not use it? You know, the likeliness of everybody memorizing dozens and dozens of formulas and rules is not very high. So anyhow, I've got my patty paper. I'm going to lay it over my graph here. I'm going to trace this origin, and I'm going to plot or trace over that point 3, 1. Whenever I'm performing rotations, I also like to indicate what quadrant my figure is in to begin with, or what point. So anyhow, I'm indicating that I have quadrant 1 here. I am going to have us rotate 90 degrees counterclockwise and determine A prime. So let's go ahead and call this point A. Okay, I've placed my patty paper back over my drawing. I'm going to use my pencils, the pointy part of my lead, as like a pressure point for the origin because I need to rotate this 90 degrees counterclockwise. We know that one full revolution would be 360 degrees, half of a revolution would be 180 degrees, and then a fourth of a revolution would be 90 degrees. So let's go ahead and rotate this. About 45 degrees. Let's keep going, and boom. There's 90 degrees. So I can see that A prime would be located at, what's this, -1, 3. Okay, not too bad. Next, let's rotate around a point that is not the origin. And let's actually use A prime this time. So let's rotate A prime about, I don't know, -2, -1, 180 degrees. I'm going to use the same patty paper that I have here. So I have my origin traced. Let me go ahead and trace over A prime. That's the point that's going to be rotated. And it needs to be rotated about the point -1. So I'm going to go back to down 1. And place that point there. What I like to do here is I do like to treat this point as a new origin in a sense. I'm going to draw this right there. And the reason I like to do that is because then I can place my pencil here and I can perform that rotation about this point. I should probably expand this a little bit so that way it's easier to see once I've hit 180 degrees. And let's go. This is 90 degrees. This is 180 degrees. So I can see here that this is where A prime would map to. And this does get a little bit trickier. I'm going to go ahead and lift, well, I guess I'm just going to count. I can still see through the paper, so I see my actual origin here and my x-axis, y-axis, all of that. So anyhow, oops, and I think I scooted my paper around on accident, so let me start over. Here we go. This is tedious work, but it's not that bad. So I'm going to place my pencil here as a pressure point. Here's 90 degrees. Here is 180 degrees, and I see that my A prime has mapped to the ordered pair -1, -2, -3, and then 1, 2, 3, 4, 5. So -3. So that's where that point would end up being. Oh, I don't know that you actually got to see it because I just looked over and I realized that it wasn't there. So let me just kind of recap that process using this patty paper. I laid my patty paper down. I traced over my actual true origin. I traced over the point A prime that was going to be rotated about the point -2, -1 right here. I did redraw like kind of like an origin here for this other point that I'm rotating about, so that way I could rotate and I could keep up with each rotation. You know, here's 90 degrees. Here's 180 degrees. Here's 270 degrees. Here's 360 degrees. Okay. Anyhow, these are quite pleasant. Hopefully this is helpful. And hopefully this will be a nice strategy for you to use so that way you get some test questions correct on our unit exam and the state test. All right, have a good weekend.